I think I'll break this solution up into two videos to try to keep the videos a reasonable length. In this problem, you're accelerating from a red light to get onto the freeway. You see a highway patrol car and then you slow down. So I look for certain key words when I'm reading a problem that help guide me to the right solution. And in this case, I see the term constant acceleration. I actually see it a couple of times in the problem. And so when I see constant acceleration, one of the things that pops into my mind is kinematics. So we can use our kinematics equations to work on this problem. Let's take a quick look at what's happening kind of visually. And so at some point in time, we're stopped at a red light. I'm just going to put v equals 0. Then we start to speed up for some period of time. And at that point we see the highway patrol. And then we hit the brakes for a little while. And at the end of that period, we're going the speed limit. So during this first period, from v equals 0 to the time we see the highway patrol car, we are speeding up. And during the second period, we're slowing down. And while we're speeding up, we have constant acceleration. And while we're slowing down, we have constant acceleration. But over this entire interval, we do not have constant acceleration. It changes, right? When we're speeding up, it has one value. When we're slowing down, it has a different value. So we have to break this up and treat it as two separate problems. So I'm going to work the first problem now while we're speeding up, and hopefully that'll be enough for you to finish the problem on your own. If not, you can take a look at the second video. And in a kinematics problem, there's certain steps we have, and one of them, the very first one I like to put here, you want to define your origin, and you want to define your positive direction. It kind of makes sense since we're starting at the red light. Let's just make that our origin. And I've already drawn my picture with the car moving to the right. That's kind of the way most of us think about motion typically, moving to the right. So I'll make the right my positive x direction. Now I can go ahead and start thinking about what parameters I need to define this motion. And there are 5 parameters. So this, again, I'm just going to write it here to make it clear. This is only for the part of the problem where we're speeding up. So what I'm going to do is go ahead and define those 5 parameters. And I always make a little chart like this to help me keep track of where everything is. I know it takes an extra 10 seconds, but believe me, it helps keep track of everything, and it helps you get the right answer. It's well worth the time to make a little chart like this. The first parameter is delta x, and I usually write it as x initial and x final. That's one thing, and because that's really all I care about, it really is delta x. But I usually write it out as x initial and x final. I care about my initial velocity, my final velocity, my acceleration, and my time. Those 5 things are what define my motion. So let's start filling in what we know. X initial, we know that. We've defined that to be our origin, so that's x equals 0. X final, that's given in the problem as 200 yards. I'm going to put in here plus 200. Why am I doing that? Because this is not distance, right? Distance has to be a positive number. This is position. These x values are position on a number line. And if we're on the positive side of the origin, it's a positive number. If we're on the negative side of the origin, it's a negative number. And my initial velocity is 0. My final velocity, I don't know. Excellent. So I'll be able to solve for that, even though there was nothing explicitly asked for in this problem. I now know I can find the final velocity of my car when I see the highway patrol officer. The acceleration, I don't know, so I can solve for that also. And the time was given as 12 seconds. So one thing I'm going to do is go ahead and convert my values. I don't particularly care for yards. I don't usually work in yards. Typically we're in meters, kilograms, and seconds. Those are the units that we like to use for length, mass, and time. So I'm going to convert this to meters. And you can find conversion tables in the back of your book probably. Or maybe your calculator has a button on it. You can punch it in. So I'll convert that to 183 meters. And and now I'm ready to go. So I can solve for those last two. If you have any three of these parameters, you can solve for the other two using your kinematics equations. So the first thing I'm going to do is solve for V final. And I'm going to choose the kinematics equation that's missing acceleration, because otherwise I'll have two unknowns, right? So I'll pick the equation that's missing acceleration, and that's this equation. X final equals x initial plus my average velocity, which is 1/2 times v initial plus v final times my time. And I always start out by writing out the kinematics equation exactly as it appears in the book or on my note card, because if you want partial credit, you've got to have something on your page that's correct. So just start out with the equation, then start putting numbers in. It'll save you aggravation later on, maybe it's a careless mistake also. So there's my equation. Now I'm going to start plugging in numbers. I've got 183 meters is my final position. My initial position is 0. My initial velocity is 0. My final velocity is what I'm trying to find. And 12 seconds is my time period. And so I end up over here, I bring the 2 over. I have 183 meters over 12 seconds. And I get 30.5 meters per second for my final velocity. And just to point out here, that's a positive number. I got positive 30.5 meters per second, which means that my velocity is to the right. I'm going to scroll back up here and put that into my table. My final velocity, I know now, it's positive 30.5 meters per second. So now I can solve for my acceleration. And I'm going to choose an equation that's missing V final, just in case I made a mistake finding V final in the last part of the problem. Maybe I pushed the wrong button on my calculator. Just in case I made a mistake, I'm going to not use that answer. If you feel very confident in that answer, you can use any of the kinematics equations to solve the acceleration now. But I'm going to choose this equation. X final equals x initial plus v initial t plus 1/2 a t squared. And I'll start plugging in some numbers. 183 meters is equal to 0 plus my initial velocity is 0. 1/2 a times 12 seconds squared. And that gets me, the 2 comes over 183 meters over 144 seconds squared is my acceleration, and that's 2.54 meters per second squared. That's also a positive value. So let me scroll back up here and enter what I get for my acceleration, a positive 2.54 meters per second squared. And this is a good sanity check. The velocity and the acceleration are both positive, which means my speed is increasing. Both velocity and acceleration point in the same direction, and they're both the same sign. your speed is increasing, and that's what we have here, right? So that's good. So as you go along, think about each answer. Make sure it's making sense to you. So even though nothing was specifically asked for, we found the acceleration during this time period. We found the final velocity, which is about 68 miles per hour if you're curious. And in the next video, we'll see how to figure out what our final speed is after that period of slowing down.